take a look at that chapter 2 study guide. I'm just going to kind of go through these and show you how we got the answers we did for these problems here. The first 9 of these, it might be helpful to grab your yellow cheat sheet to kind of look back and forth and see where these are coming from. Because on your test, you do get to use that yellow cheat sheet. And you can kind of see where these are coming from if you look at that cheat sheet. All right, first one here says, we have an if-then statement. And remember, with if-then statements, you want to figure out what they did to the if part to get to the then part. It says if AD equals the measure of angle A, then the measure of angle A equals 80. So to get from the if to the then, they flip these things around. The 80 equals the measure of angle A becomes the measure of angle A equals 80. The symmetric property is the one that allows you to flip those two around. So if you have that one on the test, you just say symmetric, or you could say symmetric property if you want. Either one is fine. The second one says if RS equals TU and TU equals YP, then RS equals YP. And what we did here is the TU's in the middle disappeared, and we put the RS and the YP together to make them equal to each other. Now, this one is set up as the transitive property. And again, you can put property on there, or just transitive. I also accept substitution. If you wanted to, since TU equals YP, technically you could put YP in for TU. So if you said substitution, I would understand where you're coming from there. So transitive property or substitution property for that one. Our third one says if 7x equals 28, then x equals 4. Once again, we have an if-then statement. We want to figure out what they did to the if to get to the then. The 7x equals 28, to get to x equals 4, what they did is they divided both sides by 7. If you divide this side by 7, you're left with x. And if you divide this side by 7, you're left with 4. Division property lets us divide both sides by the same number. That one is division property. Number 4, a lot of people struggle with number 4. If you look at the if part, it says VR plus TY equals EN plus TY. And then on the end here, VR equals EN. So what happened from the if to the then? The VR stays on the left, and the EN stays on the right. What they did is they got rid of the TY on both sides. And to get rid of the TY on both sides, they just subtracted TY from both sides. Subtraction property allows us to subtract TY from both sides. So that one's subtraction property. All right, another one with if-then form here. Number 5 says if angle 1 equals 30 and angle 2, or angle 1 equals angle 2, then angle 2 equals 30. Now, once again, we've got two things equal to angle 1, the 30 and the angle 2. Since they're both equal to angle 1, they'd be equal to each other. That one would be transitive. Or again, I would use substitution here. You could also substitute by taking this angle 2 and putting it in for angle 1 here. If you substitute that angle 2 in here, you get angle 2 equals 30, which is what we have on the end. So on the test, I would accept either of those two answers there, transitive or substitution. Number 6, pretty straightforward one. This one's not if-then form, so all we have to do is figure out which property it matches up with. It says QA equals QA. The reflexive property allows you to say that something is equal to itself. X equals X, A equals A. In this case, QA equals QA. That is the reflexive property. All right, now back to if-then form. 7, 8, 9 are both in the if-then form. Again, we have, with if-then form, we want to figure out what we did to the if part to get to the then part. In the if part here, we have AB congruent to BC and BC congruent to CE. And then on the end, we have AB congruent to CE. So the AB and the CE stay in there. The BC's in the middle that were congruent to each other, or that were the same, disappeared. So this one, again, would be transitive. We have two things equal to the same thing, so they're equal to each other. And you could also go substitution on this one. If you took the CE and put it in for BC, that would be substitution. Number 8 says if Q is between P and R, then PR equals PQ plus QR. Now, if you look at the if part, Q is between P and R. If you drew a picture of that, I'll kind of squeeze it in right here. We're going to put Q between P and R. And then it says if you add PR, or to get PR, the entire segment, you would add PQ, this little one, plus QR, this little one. This one's saying if you add the two little ones together, you get the entire thing. That is the segment addition postulate. And if they do it with angles, same thing, you could do it with angles. If you have two little angles added together to equal the big one, that would be angle addition postulate. All right, number 9, we got AB plus BC equals EF plus FG, and AB plus BC equals AC. And we're going to end up with EF plus FG equals AC. Now, in the if part, you might notice that you have two things equal to AB plus BC. The EF plus FG is equal to it, and the AC is equal to it. Since these two things are both equal to the AB plus BC, we can make them equal to each other, which is the transitive property. And then also, again, we can do substitution. If you substituted AC, let's go the other way. We took this EF plus FG and put it in for AB plus BC here. Then you get EF plus FG on the left, you get AC on the right. So substitution, we accept that also. All right, those are your properties. Now again, if it's if-then form, you're going to figure out what they did to the if to get to the end, to get to the then. Now these aren't on there, but I'm going to add a couple more. Let's say we had something like this. We're going to test you out here. If 2 times the quantity x minus 1 equaled 8, then 2x minus 2 equals 8. We have to figure out what property that is. So from the beginning, from the if part to the then part, the 2 times the quantity x minus 1 changes to 2x minus 2. The 8 on the right stayed the same. So the only thing that changed was the front part here. What property allows us to say that 2 times the quantity x minus 1 equals 2x minus 2? That is distributed. Very good. There's distributed property. Now another one that'll catch people off guard sometimes, let's say we have something like this. AB equals CD. AB plus 3 equals CD plus 3. So again, we want to figure out what we did from the if part to get to the then part. In the if part, we have AB plus CD. The then part, we add 3 to both sides. Which property allows you to add 3 to both sides? That's the addition property. Very good. So when you get these if-then when you get the if-then forms, you're going to figure out what they did to the if to get to the then. That will be your problem.
In that problem, if we have to put the segment addition or just addition?
For the last one?
Yeah.
Just addition, because we just added 3 to both sides.
Okay.
Yeah. Segment addition would be if you added like we did here, we're adding actual segments together. Yeah. Any other questions with those? Okay, let's do the 2 proofs, the 2 algebra proofs we have on there. Now remember, with algebra proofs, what we're going to do is solve the equation, and then every step of the way, we're going to tell why we did what we did. And this one, we kind of have to fill in some statements and some reasons. This nice little example here to show you some different things. All right, first thing, we're given 8x minus 5 equals 2x plus 1. We want to prove that x equals 1. And your first step, if you look at the 8x minus 5 equals 2x plus 1, that matches up with the given. So our first step is given to us. And that is almost always going to be your first step, is the given. Now, from step A to step B, the 8x becomes a 6x. The minus 5 stays on the left. The 2x disappears on the right, but the 1 stays there. So what we did is got rid of 2x by subtracting 2x from both sides. And the subtraction property allows you to do that. Step C wants us to do the addition property. Addition property lets us add the same thing to both sides. So if you look at the previous equation, 6x minus 5 equals 1. The addition property would want me to add the same thing to both sides. I would add 5 to both sides to solve this next. If I add 5 on the left, I'm left with just 6x. If I add 5 on the right, I end up with 6. There's your addition property. And then to get from step C to step B, the 6x became an x, the 6 became a 1. We got there by dividing both sides by 6. Division property allows us to divide both sides by 6. So that's the type you're going to have to be able to do on the test. If you fill in the blank, you're going to fill in the missing parts. Let's try another one of those. Number 11, we got 4x plus 6 over 2 equals 9. We want to prove that x equals 3. First step, again, matches up with the givens. First step is given. And then we're missing a little blank here. What's the multiplication property next? Multiplication property says we get to multiply both sides by the same number. Anybody look at this first equation and figure out what we multiply both sides by? 2. Yep, we're going to multiply both sides by 2. If you multiply, go ahead and do it here. If you multiply this side by 2, the 2's cancel out, leaves you 4x plus 6. If I multiply the right-hand side by 2, 9 times 2 is 18. Then, from step B to step C, 4x plus 6 becomes just 4x. The 18 becomes 12. We got from B to C by subtracting 6 from both sides. When you subtract 6, it disappears on the left. You subtract 6 here, you get 12. Subtraction property allows us to subtract 6 from both sides. And then our last step, they want us to do division property. Division property lets you divide both sides by the same number. 4x equals 12. To solve that, you would divide both sides by 4. So there's our division. We divide by 4 to get x on the left. 12 divided by 4 is 3. There's your algebra proof. All right, before we move on to the angle proofs, any questions here with the algebra proofs? Okay, the angle proofs I have on the board. So you can just kind of take a look at these up here. Connie, will you hit that light again back there, please? Okay. Here's our first one. We told you the proof of the vertical angles theorem is going to be on the test. So here's another example of the vertical angles theorem. In our given here, it says angles 7 and 9 are vertical angles, and you can see that in your picture. Here's 7, here's 9. Those are vertical angles. And we want to prove that angle 7 is congruent to angle 9. Vertical angles theorem says if there are vertical angles, they are congruent to each other. So again, we just work our way through it. First step here matches up with the given. Step number 1 is going to be given. Now, from step A to step B. Step B, we have 7 and 8 are a linear pair. If you look at your picture up here, 7 and 8, when you put those two together, they form a straight line. That makes them a linear pair. Same thing with 8 and 9. 8 and 9 are next to each other. They make a straight line, so they're a linear pair. And if you look at your cheat sheet, I think it's the last one on the cheat sheet. It's a definition of a linear pair. And basically, we just do it as a picture. If you have, I think on your cheat sheet, it looks like this. You have two angles next to each other making a straight line. That's the definition of a linear pair. So when you look at these and match it up to your picture, if they make a straight line like that, they're going to be a definition of a linear pair. Now, in your proofs, one of the patterns that you will see is once you have the definition of a linear pair, once we say they're a linear pair in the proof, then the thing we know about a linear pair is those two angles next to each other making a straight line will add up to 180. So once it's a linear pair in your proof, then you can say the angles add up to 180. So since 7 and 8 are a linear pair, they're going to add up to 180. Since 8 and 9 are a linear pair, they're going to add up to 180. And that right there is the supplement theorem. And this is one of those patterns that will show up a lot of times in your proof. You have your linear pair first, then they add up to 180. That's going to be the supplement theorem when you see those. Now, from step C to step D, in step C, we have two things equal to 180. Angle 7 plus angle 8 equals 180, and angle 8 plus angle 9 equals 180. Since they're both equal to 180, we can say that these two things are equal to each other. So angle 7 plus angle 8 is on the left, angle 8 plus angle 9 is on the right. Those two are equal to each other by the substitution property. And basically what we did is we took this angle 8 plus angle 9 and we put it in up here for 180. And now once you get to here, it's really pretty easy. Angle 7 plus angle 8 on the left, angle 8 plus angle 9 on the right. We have an angle 8 on both sides, so we can subtract angle 8 from both sides. That would leave you angle 7 on the left, angle 9 on the right. Subtraction property allows us to do that. And then another one that will show up a lot on your proofs, another pattern that will show up. In step E, we're equal to each other. In step F, we're congruent. Basically, everything else stays the same. You got angle 7 on the left, you got angle 9 on the right. The little m's, the measures disappear in front, but the equal becomes a congruent. Definition of congruence is the one that allows us to flip back and forth between congruent and equals. And with definition of congruence, you can either use the symbol or you can write out the word congruence. Either way is fine. There's our vertical angles proof. Vertical angles theorem. Any questions with that one? Okay, we got another one over here. This one, our picture is a little bit different here. In the given, LM is perpendicular to MP, and I've marked that in our picture. LM is perpendicular to MP. If you remember, perpendicular means they're going to form a right angle. So where LM and MP meet up, I put the little right angle box in there. So if that helps, you can do that. And then the other part is angles 4 and 6 are complementary. 4 and 6 right here are going to be complementary to each other. Now we need to know what that means. Complementary means they add up to what? They're going to add up to 90. So we're going to keep that in mind as we go through the proof. They're complementary. That means those two are going to add up to 90. And then we're trying to prove here that angle 5 is congruent to angle 6. We want to get these two equal to each other, or congruent to each other. All right, let's start it off. First step, it's going to match up with our givens. So there is step number 1. And then in step B, we want the definition of perpendicular. Up here, we said if they're perpendicular, that they form a right angle. So on this one, when it asks for the definition of perpendicular, we're going to actually tell what the right angle is. In this one, LMP is going to be a right angle. And we just go ahead and write that out. Angle LMP is a right angle. That comes from the definition of perpendicular. Now, step C, they filled in for us. Once it's perpendicular, we know a perpendicular lines form a right angle, and we know a right angle is equal to 90. So once we have it as a right angle, we're going to say it's equal to 90 by the definition of a right angle. That one's all filled in for us. We didn't have to really do anything with that. All right, now we go to step D. And step D sometimes is hard to find. The measure of angle LMP equals angle 4 plus angle 5. Here's where that's coming from. If you go up to your picture, here's angle LMP. Angles 4 and 5 are the two angles inside that form angle LMP. And if you remember back on your cheat sheet, angle addition postulate says we add these two little angles together, you get the big one. Here we're adding the two little angles together to get the big one. So this is angle addition postulate. And again, you can abbreviate if you want to, or you can write it all out. Step B, they put in for us. We're going to do substitution. Here's where the substitution's coming in. Usually substitution involves the two previous steps. In the two previous steps, we have two things equal to LMP, 90 and angle 4 plus angle 5. So basically, we're just taking this 90, and we're going to put it in here for angle LMP. When you do that, you get 90 on the left, angle 4 plus angle 5 on the right. That is substitution. Now, step F. This easily gets forgotten because we kind of we haven't talked about this in a little bit here. Angle 4 plus angle 6 equals 90. This goes back to your given where we said they're complementary. So if I go back here all the way to the given, we said 4 and 6 are complementary. Complementary, we said, adds up to 90. So angle 4 plus angle 6 equals 90. That's by the definition of complementary. Now we're getting close. Substitution is next. Again, substitution usually involves the two previous steps. If you look at the two previous steps, you have two things equal to 90. Angle 4 plus angle 5 and angle 4 plus angle 6. And I'm going to go ahead and put the 4 and 5 together on the left. And that'll equal the measure of angle 4 plus the measure of angle 6. So substitution, 2 previous steps, 2 things were equal to 90, angle 4 plus angle 5, and angle 4 plus angle 6. So we just put those equal to each other. Now, once we get to here, this is kind of what you're used to, subtraction. We're going to subtract the same thing from both sides. I have angle 4 on both sides, so we can subtract them from both sides. If you do that, you get the measure of angle 5 on the left, measure of angle 6 on the right. That's by the subtraction property. And then, last step, we're going to go from equal to congruent. Once again, that's the definition of congruence. Definition of congruence allows you to flip back and forth between equal and congruent. All right, a lot of stuff in that proof. Any questions with that? Okay. Let me shut down our recording here.